All right, this will work. We'll just kind of, since we're reviewing, I won't even put it in display mode. Okay, so the main thing we're going to be playing around with these problems, or one of them, is this idea of how is the land going to develop in our city? And so what we did on Monday was identify who's willing to pay the most. And so we were using the leftover principle and also looked at kind of the interaction between wages and businesses. So we've got office people willing to pay the most because of the face-to-face time being important, and being in the central business district, minimizing on those trips gives them the highest willingness to pay. And so point A ends up identifying, let me get my little drawing thing out here, which I've come to like here. So point A gives us our identification of the office district, and then the manufacturing places are willing to pay more than the residents. And so they are going to be in the city here up to X2 at point B where they intersect. So notice along this bid rent function for the city, it's always the outer envelope of the amounts showing the who's willing to pay the highest. And then our last group is the residents that we push outside. They're willing to outbid agricultural use, but not all the way. So eventually out in the rural areas past point C, we get into ag. So the ag line there is for ag uses. All right, so then that kind of identified this monocentric. We start in the middle here with the offices, then we got the manufacturing, and then we got the residential. Okay, any questions on quick review of the model setup? The other one I might point out, well, this one could come in handy too with total costs, labor costs, and freight costs. Is it cost minimizing to locate in the center or away? And then the last thing that we'll use with these problems is this model, that here we simplified things by just having we got rid of the manufacturing just to keep things simple with business and residents. So kind of the business sector and the residents. Same thing going on with the size of the city, residential area versus the business area. But the thing that was added with this general equilibrium analysis is to say the interaction between the size of land and the willingness to pay and the labor market. So we could have wages going up. We could have wages going down. And so that allowed us to feed back into maybe if businesses have lower wages, then they can afford to pay more and the business area would grow. So that's what we'll be playing around with in the problems. Questions? 10-second pause. All right, so in some of the problems, this was the streetcar example we went over. So we might have the residents being able to afford more to live out farther. And so that was a shift of the resident bid rent curve. Okay, let's get to our problem then. Whoops, wrong thing. So, number 2, consider an office firm in a monocentric city. The labor cost function is there, where X is the distance from the city center, and we're looking at a range from 0 to 5. The interaction cost for travel between the offices is C equal to 12 plus X raised to the beta. Somebody's not muted. Check your microphones. Getting a little feedback. Jessica, you might look like you're not muted.
My fault.
So the total cost for the travel between the firms, so this is for that face-to-face interaction, is 12 plus X, the distance from the center, raised to beta. So that's an exponent raised to the beta power, where beta is a parameter, a variable beyond the control of the firm. So based on the earlier discussion in the travel cost of firms, a plausible value of beta is 0.5, 1, or 2. So I think what I'd like you to do for starters to hit that is to draw yourself a little graph, or you can make a little table of numbers. Why don't you experiment what a value of 0.5, 1, or 2 does? Just because it's the square root, so something raised to the 0.5 power is the square root. So on the 0 to 5 function, if you, let's see, it looks like I have a little bit of white space here to maybe do a little drawing right on where we're at. So maybe I'll do that for this part instead of doing a whiteboard. So you can kind of think of, oops. Here's 0. So calculate the cost for beta equal to 0.5, 1, or 2 at a distance of 0 with x equal to 0. And then you can do it for, I think, why don't you go ahead and just do it for a value of 4 for now? Just because the square root of 4 is 2 and 4 squared is 16, so it kind of makes the numbers a little easy. But ultimately, we're going to do it out for 5. So you guys can kind of work. I'm going to work on it too so you can peek, but it'd be good for you to kind of start thinking about this on your own now. So
Russ, do you want us to do it for 4 or 5 or both?
You can do it for both. Ultimately, we're going to end up doing it for both. But for this first part of the question, we're just thinking about which one is more plausible for travel cost of the firms. And what the author is trying to get you to think about is what does the function look like? Does it get more costly as we move from the center or less costly? So basically, I'll kind of show you here because I can erase this easy. He's basically trying to say, does the function look like this, or like this, right? So as we get further from the center, does cost go down? Does cost rise linearly? Or does it go exponentially up? If you guys test that x to the beta function, where your first one at 4, so if we do the 3 cases of, well, we can start with at the center, what is 0 raised to any power? 0 raised to any power? Daniel, I think I saw you motion hand signal. 0. Yeah, so 0 squared is 0 times 0. So 0 to any power is 0. So therefore, the cost at 0 is easy. It's just 12 for any one of these. So 12 is kind of our starting spot for cost at the center. And so cost at beta equal to 0.5. If you guys want to open up the chat box, you can put your answers here. So 12 plus, I guess I was going to put 4 for starters here. 4 raised to the 1/2 power equals, chat box. Okay, good. Daniel's got it. 14. Let me see where I can throw my chat box. Oops. Do you guys lose the whole screen when I just did that? Did it all go blank to, or is that just my view of it?
No, it looks the same.
So let me do it again. So I'm going to do it right now. You guys are looking at the same screen?
It's still the same one that with all your graphics.
Okay. That's good to know. Okay, because my screen went totally white. So that part is not part of the share function, apparently. Okay. Okay, so yeah, we've got 14, and then what is it at 1? So 4 raised to the 1 power is 16, good. And 4 raised to the 2 power is 28. And so the question the author's trying to ask here, in fact, let me erase this part. Okay. The question the author's trying to get you to think about is which one's the more likely answer? Does it go up to 14, 16, or 28? Oops, I lost my thing. 16 or 28. And now you can do 5. And we can kind of look at what happens with each one. The square root of 5 is a little wonky, but okay, 14.24, so it's just a little bit above that. 17, so instead of 16, it's 17 for this one. And then we've got 5 being 37. And so if you were to connect these dots, we're kind of saying, does it look like that? Does it look like that? Or does it look like that? And those are the type of functional forms that give you those general looks. So notice when beta equals 1 raised to the 1 power, it's just a straight line, right? 12 plus x. The slope is 1. The intercept's 12. So this one is just a straight line, this middle one that we have here. So what did we learn from the previous chapter on the building face-to-face? Which one is it if we call this, I guess let's just call it by the numbers. Is it the 0.5 version? So this is the 0.5 function. Is it the 1 function or is it the squared function? As we move from the center, what happens? Does our cost rise exponentially, which is what 2 does? Or does it increase at a diminishing rate, which is what 0.5 does? Or is it a linear relationship? Nate Johnson says 2. I agree with you. You want to go off mute and just verbalize that? I think you're right.
So when the firm goes farther away, just the transportation costs and stuff doubles. And so it's not a decreasing function. So it can't be 0.5 because the farther you go away, the costs go up, and it's not linear because the farther you go, it's even more expensive. So it has to be the ×2. Yeah,
it was related to our principle of median location. So the further out we go, we're making way more trips basically. So it is an exponential function.
Could you say that again, please?
As we move further away from the center, the number of trips that we're making rises exponentially. So if you go back, there's a little table that the author did in the previous chapter where we looked at the office bid rent function. I can't remember what chapter that was, but a couple chapters ago. Okay, so we're dealing with the squared. So for the next part, let's go ahead and use the squared function. Let me clear this drawing. So illustrate the cost minimizing location for an office firm, including a value for X star. X star would be the optimal location. So for this one, you need to combine the 2 cost functions. So we're looking at the total cost function, and we're thinking, should we locate at the center or away from the center? So the center's here and away from the center's here. So the author was using 5 or 0 as our 2 choices. So basically, let's just calculate the cost at each location, and then we're going to pick the one that's the least. So what does our cost function look like?
60 minus 6x.
60 minus 6x, good. So we got total cost equals 60 minus 6x. And that's just the labor cost.
So the cost of travel would be the c equals 12 plus x to the
Yep.
beta power?
So we're basically going to have, that's our labor cost plus 12 plus x. And then since we learned that the squared is the most appropriate, we're going to do x squared for beta. So then we can simplify this expression. So we're adding the two types of cost together, which then gives us 72, right? 60 plus 12 is 72 minus 6x plus x squared. So what is the cost for the company at 0 at the center of the city?
72.
72. Yeah, it just collapses down. So we've got 6 times 0 is 0, x squared, 0 squared is 0. So it's pretty simple. It's 72. So in fact, let me, let's see, I'm trying to think if I should, I'll try to keep with this instead of going to the whiteboard. Let me get rid of this. I probably should have just cleared the whole thing. In fact, let me just clear the whole thing. And so total cost equals 72 minus 6x plus x squared. And so on the graph at 0, my total cost is 72. And chat box is open. What is it at 5? Okay, looks like we got some 67s, right? So at 5, we got 6 times 5 is 30. So 72 minus 30, which is 6 times 5 plus 25. So that whole thing gives us our 67, right? So 72 minus 30 is 42. 42 plus 20 is 62 plus 5 is 67. That's the way my brain works in my head anyway. So at 5, we're at 67. Okay, so if we had to pick between being in the center or being out 5 kilometers, which one would we pick? Are we going to be at position 5? Yes, so Eddie is correct. We're going to be at position 5 if that was our only choice. But now with this particular cost function, is that the minimum? So go ahead and calculate values for 1, which is pretty easy, but oops, let's see if I got to get back on my drawing thing. For 1, for all these ones in the middle, 1, 2, 3, and 4. So calculate the values, go ahead and put them in the chat box. Once you get the values, so you can put like at 1, I can do that one. 72 minus 6 is what? 64 plus 1 is 65. So 1 is 65. So x equal 1, cost equals 65. X equals 2. And somebody got 3 already, I see. X equal 3. I probably could have done a nice little table here. So x equal 3, we've got 63. At 2, what did you have? 60. Oh, yeah, 67, right. Sorry, I said that, but then I wrote the wrong thing down, didn't I? So 67. And what would you guys get for 2? 64. And then 4 was, who's got 4? I'll just kind of come down this line. We got 72 minus 24 plus 16.
4 is 64.
64. And then we already did 5 was 67. So where does the firm want to locate?
3.
3. So we minimize cost. Given these parameters at 3, our cost is going to be minimized at 63. So 63 or 3 is X star. So X star is 63 because it minimizes cost. Okay, any last questions on that one? Comments or questions? All right, well, let's do another one here. So if we scroll down to number 4, I'm not in love with this problem, but it's all right after I work through it. It does give the model insights that we're looking for. So consider a monocentric city that improves its local schools, boosting student achievement in an efficient manner. To simplify matters, ignore any effects on the increased achievement on worker productivity. So we're not going to say that long-term, maybe a higher educated workforce would make them more productive, which would increase the demand for those workers, but we're going to ignore that part. So we're thinking about the land market and the bid rent functions. So in the residential land market, let's go ahead and chat box this because I don't think you guys got to kind of get the feel for this model, and I think it's almost good to not turn to the graph right away. I'll go to that in a moment. Now that's our final thing we do, but in the chat box, if the city improves its local schools and it boosts student achievement, what would happen in the residential land market? Would that increase or decrease? All right, increase. And so we're going to show that. So Jonathan, why did you say decrease? Because I think this is, I just want to get your intuition on it.
Want to decrease because they're trying to draw people back out, back to the residential areas.
Yes, but so if it draws people out or it attracts more people, it's going to increase. So you said the right thing, but the amount of residential land market area is going to go up. So the way to think about it with this model is that that's a benefit, right? And so people are willing to pay. There's a value to that benefit. And so people are going to bid up that residential land where the school system's better. They might come from another city or something else, right? We're not really getting into where these people are coming from, but some sort of migration maybe or something else. Okay, so the residential land market, the improvement's going to lead to an increase in the residential bid rent function. So this is going to be an increase. I'm just going to use some shorthand notation. I've been using BR for bid rent residential. So that's going to be a shift outward of the residential bid rent function. Okay, now part B, in the labor market, the changes in the residential land market are going to cause what? So changes in the residential land market, what's going to happen to the land market? So in the land market, we've got labor supply and labor demand. And we've got the number of workers. And this is basically the wage, right? Maybe I should put wage here. So we got the wage. And so it starts at some initial equilibrium. Let's call it W1. What changes, the supply or the demand, when we have more people moving to a residential area because of these supply, good. So the supply is the supply of people, of households moving to a location. And so if the supply increases, what's going to happen to wages?
They also increase?
They're going to go down, yes. So Brady, correct. Nate, you said go up. Why did you say that? What's your gut telling you that we can try to correct? Or were you saying the labor supply goes up?
Yeah, that's my bad. It's not goes up.
Okay, yeah, that's fine. It just dawned on me that you might be
Completely wrong, everyone. I wish I could read it.
All right. So just to kind of make sure everybody's clear, so the labor supply curve goes up, which means it shifts to the right. So labor supply shifts to the right, causing the wage to go down. So that's our answer to part B. In the labor market, the changes in residential land market cause wages to fall. And now we go back to the business market, part C. In the business land market, if wages are cheaper, what happens? What happens in the business land market? Back to our bid rent curve. So now we're kind of thinking about this guy here, where we've got a bid rent and a residential bid rent. What happens to the business one? Let's call this B1, and this is R1, the initial or residential, or the new residential rate. So kind of R2, I guess, if I'm going in line with what we're saying. So what happens to that B1 curve? Does it shift to the right or to the left? We're using the words up and down because we are truly bidding up prices. So it is more correct in that sense to say up or down. What happens to offices and businesses' ability? So Brady says go up, right? So cheaper wages means that, using the leftover principle, that the business function could now be here. Oops, I'm using an eraser. I'm not sure what I did there. Okay, I was trying to change color to be all cute. There we go. And let me put this function back in here. And so now we have the business area growing because of it, right? So this is B2. Okay, so that is, excuse me, that is kind of your picture here for
Can anyone hear him?
Russ, we can't hear you.
Nope.
I don't know if you can hear me, but I can't hear you, Russ. No one can hear you.
All right, and that is class.
I can't even see his picture.
Back it up.
Nice.
What time is the thing due tomorrow? 11:59 or like before 2 o'clock?
Let me look for you, JC, because I don't know.
I think it's
I need to
before
know.
2 o'clock.
Jonah, I wasn't planning to study for accounting because
What's due in this class next?
Chapter
back of the book, chapter
14.
14 tomorrow.
No.
Is it tomorrow night?
I'm looking right now to see.
Hey, Luke's changed his spot of study.
5, I think.
Yeah, it's due tomorrow.
Okay.
What time though?
I'm
Midnight?
looking.
Midnight.
Yeah, it's tomorrow night, 11:59 p.m.
'Cause we
What
got two
module is it in?
5.
5.
Cool.
Yeah, the apply is so long.
Hey Jess. See you wearing the same shirt again.
Thank you.
Do you like it?
Don't sleep. I bum like every other day. So.
Same. Why is no one using the virtual screens? It's cool. No one likes it.
Y'all want to watch me play some Fortnite?
That
Remember, these sessions are recorded, so watch what you say.
Or
Russ can
PS4.
watch me kill it in Fortnite.
Xbox PS4.
PS4.
You just joined back, so.
Okay, I'm apparently back.
Woohoo!
Did just curious, what happened on your end? Did
You just stop the froze.
froze.
it just
It
froze? Okay. All right. Well, let's see if
Take
we
the time.
can not crash the system here. I was just trying to find that one picture to get you guys going on your graphs. Let's see here. Let's try this again. That was my first crash. Crash and burn. Whoops. Let's see. This one. So this is the picture that I was drawing them as we went, but that's figure 14.3 from the textbook. So again, we had, I would draw a big picture when you get into your homework for this because it gets kind of muddy pretty fast. I'm going to try to do it here. So we had, remember, an increase in the labor supply led to a decrease in the wage. And I can't write quite as tight as I could be with a pencil. The residential function shifted out. So that's going to increase our residential area. But at the same time, our business function moved on us also. And so the business area increases and the residential area increases. The total area of the residential area would be a little ambiguous, but depending on how far you shifted the curves. But that is the picture that you would need to draw. All right, 10-second pause for questions. All right, I think let me take a look at this next one to see if I want to do it or not. I might just get a start on it because I'd like to start some of the next material too, but let's take a look at it. So clear. All right. And I assume we're still recording, right? Do you guys show that it's recording? Thumbs up if you do. Okay, good. So that freeze will just, I don't know what'll happen. I guess as long as somebody's in there, I think it does it. So that was the education system. So, we had this business tax. So let's just look at number 6. And you guys, I'll leave the graphing out, but let's kind of walk through it similar to what we did for the other problem. So suppose the monocentric city imposes a tax on businesses. If we impose a tax on business in the business land market, what happens to the bid rent function for land, up or down, chat box? Okay, let me open up the chat box here. All right, up. So up means that they can afford to buy more land. Eddie, you're saying down. Nate says down. So that's what you kind of want to think about. And then now we got to change of mind. Oh, then down. Okay, Luke. Right. So if we're going to impose a tax, it is going to cause, that's something you're going to have to pay. You won't have to pay all of the tax. Remember that businesses or the consumers and producers ultimately end up sharing the tax depending on the relative elasticity of demand and supply. But inevitably, it is going to cause less. So the leftover principle would say I can't afford as much. So we're going to have it shift down. So in the business land market, that is going to shift down. The bid rent function for business. In the labor market, the changes in the business land market are going to cause what? So businesses, what's going to happen to labor market? Chat box that. Okay, I got some going down, right? So the demand for labor is going to fall. So now this would be channeling through labor demand would fall to this level. Let's call it L2. And so the wages would fall. I'm being a little sloppy because I'm using my big fat finger to do this. All right, so wages fall. Part C in the residential land market. The changes in the labor market cause what? What's going to happen when wages fall? What happens in the residential land market? So the residential bid rent function, is that going to go up or down? Less people live there, yes. I couldn't quite tell if Nate and Aaron, if that was from the previous response or not. So we think about the bid rent function for residential. There's the business, there's the residential. Now they have less wages. Is it going to go increase or decrease?
Decrease.
Decrease. So as we decrease, that's going to shift the bid rent function down. And ultimately, we're going to bump into, I haven't been drawing it, but remember the ag line is here. The ag line is the horizontal, which means the city's going to shrink, right? So there's going to be less of a residential area. So we kind of have the idea of a shrinking city when we start to get an increase in business taxes, holding other things constant. Okay, 10-second pause for questions. All right, well, let's get a start on the next chapter 15 with the 10 minutes we got left. I think this is where I want to go. Okay, so this is kind of a fun chapter. I think I'll try to go to this presentation mode. I don't know if this is going to work. Let's see. So you guys got that, which is not what I want you to have. So let me stop the share. I am curious if I can actually do this. I think I can. Share screen desktop 2 or desktop 1? I think it's desktop 1 apparently. Yeah. Okay. So you guys looking at a full screen that shows the cover of the textbook? Okay. This is where it gets a little wonky, but now this is actually kind of nice. I've got 2 screens at home, so I'm trying to play fiddle here. So we're going to look at neighborhoods, and this chapter is going to get into the composition of neighborhoods and the compositions of the city. So now let's see, how is this going to work? Can I still annotate on this? This is going to be, oh no, I won't be able to. I'd have to use a mouse. Okay, that's going to be the difference here. Okay, I don't like this because I can't touch my screen anymore, I don't think. Wait a second, let me try. Sorry. You guys get to hear my thought process out loud now. Yeah, okay, that's not going to work. Okay. So I bet what I'd have to do is I'd have to go like this. Oh, I could try it. It kind of sucked, but all right, let me All right, I'll try this because I'm not going to do a lot of writing, I don't think, or if I end up doing some writing, I might switch it around. Okay, so the concept of a neighborhood, right? Within the city of Ottawa, even we have neighborhoods. So we can live in the, the industrial area or north of the tracks or south of the tracks. So we have neighborhoods within a given city. And so, what are some things that make you decide on a neighborhood? So let's go to the chat box on this, if you guys could. I'd like all of you to enter a chat on this. So what are some things that would make the household choose a certain neighborhood? There's lots of different reasons. So let's kind of look at what you're thinking. Schools, parks, cost, safety, good. Houses nearby and their value. So yeah, what is the value of the housing? Commuting costs, great. So if you're on the north side or you living close to work like I do, where I'm just a couple blocks from Ottawa University. Noise, do you live near a train? Do you live near an airport or something? Maybe it's a bar district or something where people are getting crazy when the bar closes, hooting and hollering and puking on sidewalks and other things. So all of those things can factor in real fast. And so what about our neighborhood compositions with income, education, and race? So this chapter is going to explore, do we have a bunch of high income people, low income people moving around? And then is segregate. So we're talking segregation, which is, I've always found it to be kind of a heavy word to use, where because segregation was banned, the Martin Luther King stuff that we learn about in January, right? Civil rights that we don't have whites and blacks using different water fountains and going to different schools. So, but the term segregation is a little lighter than that technically. And so we can have people voluntarily segregate, right? So do we see voluntary segregation where people of the same race congregate together, people of the same religion, people of the similar income, education levels? So we're going to look at all that type of stuff in this chapter, and what are the forces that cause people to do that. Okay, so so the measurement for distribution of people and the mixing of people in different neighborhoods, the most common measure is this dissimilarity index. So we're going to look at people in different neighborhoods and try to indicate whether there's a disproportionately high number of one group or the other. So for instance, let's say that the population has 20% of the people are living on less than $40,000 a year. So in a given city, let's take Ottawa, we have 20% of people living on less than $40,000 a year. And so the question becomes, where are those people living within Ottawa? And so if we look at, let's just take two neighborhoods, north of the tracks and south of the tracks. Or we could take north of the river, south of the river where the Meridazine is. So either way, we can, north side, south side, whatever, it doesn't really matter. And so if we have perfect integration, then if I look at the neighborhood north of the tracks and I sample those people, 20% of them will have incomes less than 40,000. And if I sample people on the south side of the tracks, 20% of those people will have it. Now, if instead I go to the north side and I find that 40% of the people, maybe I should say 50% just to get off of the 40. So 50% of the people on the north side have incomes of 20% or less. And on the south side, it's different. Now I have dissimilar neighborhoods. Okay, let me pause there for a second. Are you with me conceptually on what we're going to attempt to measure? Thumbs up if you do so far. Okay. All right. So the formula ends up being a value of 100 for perfect segregation and 0 for perfect integration. So here's the formula where it gets a little bit weird here. So in fact, I'm going to switch my screen around because I want to be able to write on my screen. So let me escape from this. Wait, I gotta put this on mouse. Maybe what I'll do is just make it big over here. All right, stop share. Screen share, desktop 2. Okay.
We also have like 1 minute left in class.
Oh yeah, cool. I will utilize every minute of it, but thank you for that. I'll try to be timely with it. All right, so here's the formula. And we'll definitely expand on this later, but this would be good to just look at this now while it's maybe fresh in our head. So north side, south side. So there's n neighborhoods. Let's just say n equals 2, right? And we've got AI as the population of type A in neighborhood I. So we have 100 people in a community of 1,000. We've got 100 people in the 20%, 40,000 income or less category, and we have 900 people in the other. So A is, little a and little b is the population of that type in each neighborhood, and A, big A, is the citywide population and the citywide population of B. And so by doing these ratios, if it ends up being the same as I went through before, then you're going to get 1 minus 0 plus 0 minus 1, and it collapses to being 100. Or you're going to end up getting a 0 here, and 0 is the other extreme. So we'll kind of pick through that formula on Friday, so you guys can get started on your stuff. I'll stay on the line a little bit longer if anybody wants to talk.